We are going to discuss wildcard masks in these visuals. So let's start our discussion. Here you can see, we have discussed IP addressing and we have looked some examples of IP addressing scenarios and etc. You can see subnet mask is in this form. This is the list of class A, B, C default subnet masks, whereas wildcard masks are something like this. You can see wildcard masks are written in this form 0.255.255.255 for class A, for class B 0.0.255.255, and for class C 0.0.0.255. We use wildcard masks with access lists, but I am explaining you wildcard masks here because we have in our tempo of IP addressing and subnetting, so we can do wildcard mask with all this. So just memorize that the reverse of subnet mask are known as wildcard mask. You can see how it is written, and we are going to look some examples where we can easily compute wildcard mask of any subnet mask. So we have gone through some examples. At this stage we are very comfortable with IP addressing. So we have gone through some examples through which we have I can give my analysis that each subnet mask provides a block size on any octet wherever. So that block size -1 will give us wildcard mask. How? We're going to some examples where we can finally compute wildcard mask. Here it is the network and it is the subnet mask. So we are going to look at subnet mask. So you can see fourth octet, it is 252. So 252 subnet mask provides the block size of 4. I just mentioned this. I should not mention because I just mentioned for easiness. I am comfortable without this chart. So I know that 252 gives the block size of 4. So 4 minus 3. So here we are with our wildcard mask. So for this network, wildcard mask should be 0.0.0.3. So wildcard masks are used in network address translation and access control lists. I am explaining you here. Then we will going to just put these wildcard marks in the scenario of access control lists and network address translation. It is the best time to know wildcard mask. So we will conclude it with 0.0.0.0.3 is the wildcard mask for this subnet mask. Let's move towards another example, and here it is. In our previous example, the subnet mask was long. It was on 4th octet, but here you can see the subnet mask is ending on 3rd octet, 240 and then .0. So for this 240, subnet mask gives the block size of 16. So 16 minus 1, it is 15, but the .0, here you will put all values 255. This is the way to compute wildcard mask. If the subnet mask is long, covering 4th octet like previous example, so just you're going to deduct 1 from the block size which is given, which the subnet mask is giving. But any octet, if for example it is the 3rd octet, so 3rd octet subnet mask is giving the block size of 16. 16 minus 1, so this will be placed on 3rd octet. The starting values would be 0.0.15, and the remaining where the 0 is, it will be mentioned by 255. Let's look another example. Here it is. Now this time we are moved towards 2nd octet. So this 224 subnet mask provide the block size of 32. So this is the formula: 32 minus 1, 0.31 dot remaining dot 0.0. Just look at this, to dot 0.0, put all values, put all bits on 0.31 dot 255 dot 255. This is easy. Just look at these examples again and again. You will feel comfortable with wildcard marks, and you can easily work with wildcard mark while using access control, this and network address translation. So with this I am concluding this visuals. We have discussed wildcard mask. It is actually the reverse of subnet mask, although things are same, just 0.255.255.255. It is the class A wildcard mask. So with this I'm concluding this visual. We have discussed wildcard mask. Look some examples of wildcard mask. If you feel any problem, just replay these visuals. Be prepared for upcoming visuals. Thank you.